This is mathheals.com, where you can find more links to math and computer science YouTube videos. And let's take a look at the derivative and the tangent line problem. Go over some concepts first. If we have a graph, and you got a line here that intersects at one place. If the line intersects the graph at one place, this is referred to as a tangent line. Now the slope of this tangent line is the same as the slope of that point on the graph. So if you're trying to find the slope at that point, or the rate of change at that point on the graph, if you find the slope of the tangent line, then you have that slope. Now if I have another graph that intersects in two places, two or more actually, because your graph could go back, do a little curly number here where it curls back around, loops back around. But if it's two places here, then this is referred to as the secant line. Okay, so let me draw a graph here. There we go. And I've got a point here, and we'll have a point here. And I'll draw a secant line through these. There we go. Now if I looked at this point here, coming down to the x-axis and going over to the y-axis, this is the x-axis, this is the y-axis, f of x. We're trying to find out what this distance is here. Well, we just label this as x. We don't know what it is. It could be 3, it could be 4. Let's pretend it was 3. To find out what the y value is, we just plug 3 in for the x here, so we'd find f of 3. We don't know it's 3 though, it's x, so this will just be f of x. Whatever value you have down here, you just put inside the parentheses here. Now our second point over here. Imagine that's a straight line going down. And this is a straight line going over. Well, the distance from here over to here, this is going to be represented by change in x. It's how much x is changed by. So if this distance from the origin over to here is x, and this distance is delta x, that delta represents change in, Greek symbol, then this over here will be x plus delta x. And that'll give us this x part for this point. Well, remember what we did here. You take whatever you got down here and you plug it into your f of x. So we're going to take whatever we got down here and we'll plug it into our f of x. So this is going to be f of x plus delta x. Okay, so now we got 2 points. This one right here is going to be x, f of x. This one up here is going to be x plus delta x, and then f x plus delta x. So it's going to be a point. So we got 2 points now. Okay, now refresh your memory. When we're finding the derivative, and I'll indicate, I'll put that as SCC for, or that derivative, the slope. When we're finding the slope of the secant line, that's the change in y over the change in x. And we had a formula that said if you got 2 points, then you got y2 minus y1, x2 over x1 from college algebra. So I'm going to subtract my y parts. Well, for this point, my y part is f of x plus delta x. For this one, it's f of x. So our change in y is going to be f of x plus delta x minus f of x. There we go. And then our change in our x. Well, this particular x part right here is x plus delta x, and this one is x. So I'll subtract them. So I got x plus delta x minus x, which gives us f of x plus delta x minus f of x. And x minus x cancels away, and you're left with delta x down below. So that is our slope of the secant line. Okay. Now imagine this secant line. I'm going to take this point's going to remain stationary. This one I'll move closer down. I'll move it down to there. I'll move it down to here. And as I keep moving those, now here's this one. Then my delta x is going to look like this. So it's smaller, isn't it? As I move it down to here, then this delta x is going to be smaller. So delta x, as I move this point closer and closer down, is going to get smaller and smaller. Eventually, as I move it closer and closer down, then it's going to become, the secant line will become the tangent line. And that leads into this next formula. Our derivative is going to be f prime is equal to limit as delta x goes to 0. So as delta x becomes smaller and smaller of the formula we just found. F of x plus delta x, try that again. There. X plus delta x minus f of x over delta x. So that's the formula we're going to be working with. Now that'll give us the derivative, which will help us get the slope at any point. That's kind of a generic form that allows us to be able to find a slope or the rate of change of the graph at any point. Which again, the slope, the rate of change of the graph at any point equates to the slope of the tangent line. So they're kind of one and the same. So let me save that. Just about there. Tangent line. Problem. And then page 01.pdf. There we go. Okay, let's look at our first problem. It says find the derivative by the limit process. In this section, we'll look at the hard way to find these derivatives, and then the next section we'll look at the shortcut way to do it. So this is going to be finding the derivative. Our first step is to find f of x. This will be the easiest one. This will be given. F of x is equal to 3 minus x squared. I didn't used to have this step here, but then every semester I would have somebody ask me, well, how do you find f of x? It's like, well, it's given. So this is specifically pointing out what f of x is. Second step, we want to find f of x plus delta x. Now this is just evaluating a function. So to find f of x plus delta x, we're going to go to our original function. Wherever we have a x, we'll put in parentheses. Everything else remains the same. The 3, the minus, the squared. I just replace the variable with parentheses. Now whatever's inside the parentheses here is what's going to go in over here. So I'm going to plug in x plus delta x. Give us 3 minus x plus delta x times x plus delta x. That's what x plus delta x squared means. So I'll give us 3 minus x times x is x squared. X times delta x is x delta x. Delta x times x is x delta x. And delta x times delta x is delta x squared. Which gives us 3 minus x squared. Now x delta x plus x delta x, these are both the same. So we'll add the numbers in front of them, which are invisible ones. And this becomes 2x delta x plus delta x squared. Negative in front of your parentheses flips the sign of everything inside. So this becomes 3 minus x squared minus 2x delta x minus delta x squared. Okay, step 3. Plug in f of x and let me write that a little bit more legible. And f of x plus delta x into our formula and find a limit. So f prime is going to equal to the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. So that's the limit as delta x goes to 0. F of x plus delta x from step 2 we said was all this. So we'll put in 3 minus x squared minus 2x delta x minus delta x squared minus f of x. Now notice I put parentheses around this. You want to make sure when you do this, put parentheses around it, because this minus here has to affect everything that follows it. And from step 1 we said f of x was 3 minus x squared. So plug that in. All over delta x. So we got limit as delta x goes to 0 of 3 minus x squared minus 2x delta x minus delta x squared. Negative in front of your parentheses flips the sign of everything inside. So this becomes a negative 3 plus x squared over delta x. Now we always want to combine together like terms at any point. And here I have 3 minus 3. Those are going to cancel. Here we have negative x squared. Here we have a positive x squared. Those are going to cancel. So we're left with negative 2x delta x minus delta x squared over delta x. Now you notice up on top, both items there have a delta x. So I'm going to factor out a delta x. And that leaves us negative 2x plus, okay, I'm lying, I'll try it again, minus delta x, all over delta x. Now notice up on top here we have delta x times something. Since that's multiplication, we can cancel the delta x here with the delta x here. Now the delta x down below is what was causing us problems. Because if I put 0 in there, I'd have 0 in the denominator. Well, after I've canceled there, you notice we're left with negative 2x minus delta x. Our goal is to get rid of that down below so we can plug it in. And now we can plug in the 0. So we've got negative 2x minus 0, which ends up with negative 2x. So that's our answer. Now that formula is kind of hard to work with. So I'm going to modify it slightly for the rest of the problems. So to find derivative, our formula we're going to use is f prime is equal to limit as h goes to 0 of f of x plus h minus f of x all over h. For some reason, I've seen that delta x there throws people, even throws me sometimes. Putting another variable there actually will help people solve these problems without making as many mistakes. Now you can put any variable there, just don't put x. H, p, whatever. Let me save this and then we'll do the next problem. Okay, number 2. Given f of x is equal to 1 over x minus 5. Step 1. Find f of x. Well, it's given. That's an easy step. Step 2. Want to find f of x plus h. So we're going to go through our original function. Wherever our x was, we'll put parentheses. Everything else remains the same. So again, I just went to here, replace the x with parentheses. Now whatever's inside parentheses here is automatically what we're going to put here. So we'll put in x plus h. And so that gives us 1 over x plus h minus 5. Step 3. We'll find our limit now. So f prime of x is going to be a limit as h goes to 0 of f of x plus h minus f of x all over h. Now the h is what's causing us a problem down denominator, because I can't put a 0 in for it. So again, our goal is to get rid of that h. So we're going to have limit as h goes to 0. F of x plus h in step 2 we said was 1 over x plus h minus 5 minus f of x, and from step 1 we said that was 1 over x minus 5 all over h. Now this is a complex fraction, complex rational expression, if you want to think of it that way. But for complex fractions, the very easiest way to simplify them is to multiply everything by the LCM of all your inner denominators. Now the x plus h minus 5 and the x minus 5 are our inner denominators. So we're going to multiply everything by x minus 5 times x plus h minus 5. That's our LCM. So we'll multiply times our first fraction. We'll multiply it times our second fraction up here. And we'll multiply it times the h down below. Now we won't actually multiply it through down below, because we're hoping that h will disappear. That's our goal anyway. Well, this x plus h minus 5 will cancel that x plus h minus 5. This x minus 5 will cancel that x minus 5. So let's write down what we have left. Limit as h goes to 0 of x minus 5 minus x plus h minus 5. Now notice I left parentheses around that because that minus in the middle has to change the sign of everything that follows it. Over h times x minus 5 times x plus h minus 5. Well, the up on top, the x minus 5 carries down. Negative in front of your parentheses flips the sign of everything inside. So this becomes a negative h minus, or negative x minus h plus 5 over h times x minus 5 times x plus h minus 5. So then this x cancels this negative x. This negative 5 cancels with this positive 5, and up on top we're just left with a negative h. And then on the bottom, h times x minus 5 and x plus h minus 5. Well, now these h's are going to cancel. So that's going to cancel with that. And we got limit as h goes to 0 of negative 1 over x minus 5 times x plus h minus 5. Now our goal was that h to disappear down in the denominator, and it did, so that's good. We can now plug 0 in for h. Just do a direct substitution. So I got negative 1 over x minus 5 times x plus 0 minus 5. Well, this is x minus 5 and this is x minus 5, so this becomes negative 1 over x minus 5 squared. And that's our derivative. Let's save that page. grab a drink also, and then we'll work the next problem. Okay. We got f of x is equal to the square root of x minus 2. And same instructions, find derivative. I think the next one changes. Yeah. Okay, so this is going to, our first step is going to be find f of x, which is easy, it's given. Second step is to find f of x plus delta x. Again, we're going to go back to our original function, and where our x is, we'll put in parentheses. Everything else remains exactly the same. Square root minus 2, we just replace the x with parentheses. Now whatever's inside the parentheses here is what we put in over here. So we're going to put in our x plus delta x. So that gives us square root of x plus delta x minus 2. So step 3. Plug that into our formula and find the limit. Limit as h goes to 0 of f of x plus delta, or not delta, h minus f of x over h. So then we got limit as h goes to 0, f of x plus, oh, I got delta x up there, don't I? Boy, I don't want that. Sorry about that. That's how I learned it way back when. It's a delta x. It's hard to break out that pattern. I know it's easier to have an h there, though. Okay, so f of x plus h is square root of x plus h minus 2 minus f of x, which is the square root of x minus 2, all over h. Now this one is the conjugate method. If you got square roots of some form up on top, try to multiply the top and bottom by the conjugate of the top. Now the conjugate, the first is the same and the last is the same, the sign in the middle is different. So we got x plus h minus 2 and square root of x minus 2. So those are the same. This has a negative in the middle, so this will be a positive. And you'll multiply the bottom by that too. So square root of x plus h minus 2 plus square root of x minus 2. Now our goal on this is for the h to disappear down here. So up on top, when you're multiplying conjugates together, it's really nice. All you have to do is multiply your first parts together and your last parts. Now notice how this square root of x plus h minus 2 is the same as this square root. If your square root's the same and you're multiplying them together, so square root of x plus h minus 2 times square root of x plus h minus 2, the square roots drop and you're just left with what's underneath. So we got x plus h minus 2. Minus, now put parentheses here, because that minus has to affect everything that follows it. Square root of x minus 2 times square root of x minus 2 is just x minus 2. Now the bottom part I'm not going to actually multiply together, I'll just put them next to each other. Because again, we're hoping that h will disappear. There we go. Now remember what a negative does out in front of your parentheses. Flip the sign of everything inside. So we got x plus h minus 2 minus x plus 2 over h times square root of x plus h minus 2 plus square root of x minus 2. Well, the x here minus x is going to cancel. Negative 2 plus 2 here are going to cancel. So we're left with the limit as h goes to 0 of h over h times the square root of x plus h minus 2 plus square root of x minus 2. Now down below, here we have h times something. So that h down there is going to cancel with h up here. So it's going to cancel. So this becomes a limit as h goes to 0 of 1 over square root of x plus h minus 2 plus the square root of x minus 2. And again, that h is what was causing this problem, and it's now gone, so we can plug in our 0 for our h and get our answer. Well, this becomes x plus 0 minus 2 plus square root of x minus 2. Now the 0 drops away, and this is square root of x minus 2, and this is square root of x minus 2. So this just becomes 1 over 2 square root of x minus 2. If the square roots are the same and you're adding them together, then you add the numbers in front of them, or subtract them as case may be. In this case, we got positive, invisible 1 and invisible 1, so it just gives us 2. And that's our answer. Let me save that. Grab a drink here. And let's take a look at the next one. I'm given f of x is equal to x squared plus 1, negative 3 and 10. And the instructions say, find the slope of the tangent line to the graph of the function at the given point. So finding the slope of the tangent line at a given point. Okay, our first step is to find our derivative. And there's 3 substeps within that. First thing we need to do, remember, is to find f of x. On this one, f of x is equal to x squared plus 1. Then our next substep is to find f of x plus h. I'm going to use this notation. So we've got f of x plus h equals. Now remember, evaluating a function, you go through your original function, x squared plus 1. Everywhere you have an x, put in parentheses. So we've got parentheses squared plus 1. Whatever is inside the parentheses here is what you put in over here. So this is going to become x plus h. Now x plus h squared means x plus h times x plus h. You can't just square the x and square the h because of the plus in there. If everything's multiplication or division inside your parentheses and you're raising it to a power, you can just take everything to that power. X times x is x squared, x times h is hx, h times x is hx, h times h is h squared, plus 1. Now hx plus hx gives us 2hx plus h squared plus 1. C. Plug f of x and f of x plus h into your formula. And find the limit. So we got f prime. So I write that a little bit more legible. F prime is equal to limit as h goes to 0 of f plus x plus, not delta, quit writing those, f of x plus h minus f of x all over h. Okay. This then gives us limit as h goes to 0. F of x plus h from b, 1b, we said was x squared plus 2hx plus h squared plus 1 minus f of x. And from 1a, we said f of x was x squared plus 1 all over h. Well, if you got a negative in front of your parentheses, remember it flips the sign of everything inside. So we're going to have x squared plus 2hx plus h squared plus 1 minus x squared minus 1 all over h. Combining it like terms, x squared minus x squared is going to drop away. 1 minus 1 is going to drop away. So we're left with the limit as h goes to 0 of 2hx plus h squared all over h, which the top part both have an h, so I'll factor that out, and that gives us 2x plus h, that's h squared h all over h. Now since this is h times that, those h is going to cancel, and we're going to get f prime of x is equal to limit as h goes to 0 of 2x plus h. Again, our goal was to get rid of that h downstairs, which is now gone. So then we can plug in our 0 for h. It becomes 2x plus 0, or f prime of x is equal to 2x. Now step 2. Change your derivative notation so change your derivative notation to m and plug in the x part of the point and simplify. Okay, so we found f prime is equal to 2x. But that says change derivative notation to m. So f prime is going to become m. And it says plug in the x part of the point. Well, the point I'm referring to is up here. We're given this point. This right here is the x part of a point. So we're going to plug -3 in for the x. So come down here, and I got 2 times -3. 2 times -3 gives us -6. So that's our answer. M is equal to -6. Let me save that. And let's look at our last problem. Given f of x is equal to square root of x plus 2 at 0.73. Now this is asking us to find the equation of the tangent line. So find equation of the tangent line. Okay. Step 1. Find the derivative. We're going to see in the next chapter or next lesson these find derivatives a lot easier than doing these 3 sub-steps. Our first sub-step is to find f of x. Well, f of x is given, so it's just square root of x plus 2. And our next sub-step is to find f of x plus h. And remember, what we do here is we're going to plug in x plus h for our x. So this becomes the square root of x plus h plus 2. And then we're going to plug f of x and f of x plus h into our formula. And find the limit. Okay, so we got f prime is equal to limit as h goes to 0 of f of x plus h minus f of x all over h. So limit as h goes to 0. F of x plus h from 1b we said was the square root of x plus h plus 2 minus f of x, which is the square root of x plus 2 from 1a, all over h. Now this is a conjugate method. Excuse me. When you have a fraction, you have a radical of some sort up on top. You try to multiply top and bottom by the conjugate of the top. So this will become the square root of x plus h plus 2 minus square root of x plus 2 all over h times, and again the conjugate, the first part and the last part are the same, so this is square root of x plus h plus 2, and this is square root of x plus 2, but the sign in the middle changes. It was negative, so this becomes positive. And whatever we multiply by the top, we have to multiply by the bottom. So we multiply the bottom by the square root of x plus h plus 2 plus square root of x plus 2. Okay. Now up on top, when you're multiplying conjugates together, again, all you have to do is multiply your first parts and your last parts. So I'll take square root of x plus h plus 2 times square root of x plus h plus 2, which gives us x plus h plus 2, minus, then the square root of x plus 2 times the square root of x plus 2 is just x plus 2. Again, when the radicals are the same like that, it just drops away and leaves you what's underneath. The bottom part I'm not going to actually multiply through, because again, we hope that'll simplify. And cancel. Okay, so up on top. X plus h plus 2. The minus out in front of our parentheses, we'll flip sign everything, so it becomes a negative x minus 2 over this. Well, the x minus x is going to cancel. The positive 2 and negative 2 are going to cancel. So we end up with a limit as h goes to 0 of h over h times the square root of x plus h plus 2 plus the square root of x plus 2. Now again, down below we have h times something, so these h is going to cancel. And we got limit as h goes to 0 of 1 over square root of x plus h plus 2 plus the square root of x plus 2. Well, now we can plug our 0 in. So we got 1 over square root of x plus 0 plus 2 plus square root of x plus 2. 0 really doesn't do anything there, so it drops away. So you got square root of x plus 2 plus square root of x plus 2, which gives me 1 over 2 square root of x plus 2. And that's our f prime. I know this is, I'm trying to make sure this all fits on one page, so it's not flowing quite as smooth as I'd like, you know, layout-wise. But you get the idea, with arrows anyway. Step 2. Change our derivative notation. I'll just say f prime. Change f prime of x to m. Now it could be y prime, so it doesn't have to be f prime. And plug in the x part of the point. So we got f prime is equal to 1 over 2 square root of x plus 2. And we're going to change f prime to m. Okay, if we come up here, the x part of our point, that's a 7. So we're going to plug 7 in for the x. So I come down here, I have 1 over 2 times 7 plus 2, which gives us 1 over 2 square root of 9. Square root of 9 is 3, which means we get m is equal to 1/6. And step 3. Plug in the m from step 2. and the given point for x and y into y equals mx plus b, and solve for b. Okay, so we've got y is equal to mx plus b. If I scroll up here, this is our x, and this is our y. So we'll plug in 7 and 3 for our x and our y. So this will be 3. M from step 2 we said was 1/6, and this was 7 plus b. And then we want to solve for b. So we've got 1/6 times 7, that gives us 7/6 plus b. Take 7/6 to the left side, so we got 3 minus 7/6 equals b. Or b is equal to 11/6. This is a mixed number. I took 3 times 6 is 18, plus a negative 7 gives us 11. Now step 4. Write your answer. It was wanting the equation of the tangent line, which is y is equal to mx plus b. Now from step 2 we said m was 1/6, so I'll plug that in. And from step 3 we said b was 11/6, so I'll plug that in. And our answer is y is equal to 1/6x plus 11/6. Now some people combine 3 and 4 together and use something called the point slope form for solving it. I quit teaching that a long time ago when I had a student from Japan asked me why I was showing it, and I said, well, you needed both, depending upon what the problem looked like. And he proceeded to prove me I was wrong. You could do everything with slope-intercept form, and with very little extra work. So I like one formula that works 100% of the time. Let me save this. And there we go. And I think that was the last problem. Let me double check. Yeah. So let me stop the recorders. And we're done with that section.